Hello everyone, welcome back to Smart Edits YouTube channel. My name is Ankit Patel and today we are going to discuss the Leetcode Biweekly Contest 133 problems. So without wasting any time, let's start with the first problem, that is find minimum operations to make all the elements divisible by 3. So here in this problem you will be given an array nums. In one operation either you can add plus 1 or you can subtract minus 1 to any one of the elements of the nums. Now we need to find the minimum number of operations to make all the elements of the nums divisible by 3. Question is kind of straightforward. Let's try to look at the example here where you are given an nums array. Let's say nums equal to 1, 2, 3, 4. Let's try to look at element one by one. Okay, if I take the element 1 here, now I want to make this element divisible by 3. Now if you look at to make this element divisible by 3, either I can make it 0, either I can make it as 3. But to make 1 as 0, how many operations we need to perform? To make 1 as 0, only one operation I need to perform, that is a minus 1. If I do 1 minus 1, it will be 0. But to convert 1 to 3, we need to perform two operations here, plus 1 and plus 1 here. 1 plus 2 would be 3. As we need to find the minimum number of operations to make all the elements of nums divisible by 3, I will be considering this operation. Okay, let's try to look at the second element here, 2. Now for 2, it is not divisible by 3. When it is not divisible by 3, what are my options? I can convert 2 to 0 or either I can convert 2 to 3. Now to make 2 as 0, how many operations I need to perform? Again I need to perform two operations here. Minus 1 one time, minus 1. 2 minus 1 would be 1 and 1 minus 1 would be 0. Or I have one more options. I can perform a single operation, that is plus 1, which will convert 2 to 3. And now, as I want minimum number of operations, I would be taking the second one here. Okay, let's try to go with the third element, 3. 3 is already divisible by 3, so I do not have to do anything. Now let's come back to 4. For 4, what are my options again? I can make it 3 or I can make it as 6. Now, to convert 4 as 3, how many operations I need to perform? Only one operation. That is subtracting the minus 1. Now, to convert 4 to 6, how many operations I need to perform? Two operations. That is plus 1, then it will be 5. One more plus 1, then it will be 6. So, as I want to find the minimum number of operations, I will be taking this one. Now, same thing. So, how many total operations do we require? Minimum number of operations to make all the elements of this nums array divisible by 3. 3 operations. One operation here, two operation here, and the third operation. Similarly, if you look at the second example, 3, 6 and 9 all are divisible by 3. So, 0 operations I can say. And can you find any observation, like can you make any observation here? Okay, what is the observation here? So can I say that here, if my nums of I is divisible by 3, how will I know it is divisible by 3? Simpler models 3 equals to 0. If that is the case, I won't be doing anything. I won't be adding, like my operations will not be increasing. But if that is not the case, okay, if that is not the case, can you guys tell me, to my number of operations, many should I add? Plus 1 or like 1 or 2? Every time it will be plus 1 only. When it is not equal to 0, like when it is not divisible by 3, simply I can increment it. Yes or no? So this is the observation here. When it is divisible by 3, don't do anything. When it is not divisible by 3, increase the operation. That is only the one operation. There will be no case when you need to have the increase the operation by 2. I hope the question is, like, entire logic is clear. Let's go to the code part. I'm going to do the same thing here. I will be first having my operations equal to 0. Next, I will be going to each and every element. Okay, I need to find the length here or size. As we have discussed in the logic, if my nums of y modulus 3, what we have discussed, if it is not equal to 0, that means if it is not divisible by 3, I will be incrementing my operations by 1. At the end, I will be returning the number of operations here, total number of operations. Simple straightforward question, same thing we are doing here as well. Okay, let's run once. Okay, let's try to submit it as well. Yeah. Okay, now let's see the second problem, that is minimum operations to make binary array elements equal to 1. So there are two variations. So let's try to see the first variation here. You are given a binary array nums. I hope you understand what is a binary array. Binary array is nothing but an array which contains elements only, that is 0 and 1. 0, something like this, like elements will be either 0 or 1. That is nothing but a binary array. You can do the following operations on the array any number of times. Possible is 0, so we can perform the following operations on the array any number of times. What is that operation? Choose any 3 consecutive elements from the array and flip all of them here. So basically he is trying to say that if I am picking an index I element, I can flip all of them, like I plus 1, I plus 2. This thing is nothing but a 3 consecutive element here. Index I plus 1 and I plus 2, consecutive 3 elements. I have to flip all of them. Flipping an element means changing from, like, values changing from 0 to 1 and from 1 to 0. What is mean by flipping? If the element is 0, it will become 1. If the element is 1, it will become 0. Now, we need to return minimum number of operations required to make all the elements in nums equal to 1. If it is impossible, return minus 1. Okay, let's try to see the first example here. In the first example, you will given something like 0, 1, 1, 1, 0, 0. This is the binary array that is given to you. What is the operations we can perform here? We can pick any 3 consecutive elements. As I told, consecutive elements is nothing but if I am picking an element, index I element, I plus 1 element and I plus 2. These 3 will be the consecutive 3 elements here. And we can flip all of them at once. Like, we can flip all of them here. Now, we need to find the minimum number of operations to make all the elements as 1 here. So here, as given in the first example, I can pick this index 0, let's say 1, 2, 3, 4, 5, index 0 element. Now what I have to do? I have to convert this to 1. I need to pick these 3 consecutive elements at a time and I need to flip them. So if I flip them, what will happen? 1, this will become 0, this will become 0. Now again, what is the remaining elements here? 1, 0 here. Now what is the next step? This is the first operation. In one operation we have did this. What is the next thing that I can do? Next, I can pick these 3 consecutive elements in my operation 2. Now if I'm picking these 3 consecutive elements, I need to flip 0 to 1, 0 to 1, 1 to 0, 0 and 0. Nothing changes to the remaining one. This is the thing I have done in my second operation. Now in my third operation, what I can do? See, this is already 1, this is already 1, this is already 1. I do not have to do anything. I can pick these 3 consecutive elements and I have to flip them. If I flip them, it will be something like 1, 1 and 1. And if you look at all elements in the nums array are equals to 1. So total how many operations we are taking here? 3. That is also nothing but the minimum here, like, and in the output as well given as 3. Second example, if you try to look at, it is impossible to convert the nums array into nums array into elements containing all ones, so we are printing -1. We can solve this problem, but if you think in a direction that you will be taking the consecutive element, like consecutive 0 elements, and then you will be flipping it again, you are finding a consecutive 0, again you are flipping it, just because here minimum number of operations are given, then you are complicating the problem and it will be difficult for you as well to come up with the solution. Actually, this is a standard Leetcode problem where something like this is given, that consecutive elements and you need to flip and find minimum number of operations. Simple solution here would be, you will be going element by element. What do I mean by element is, let's say this is the array. Okay. This is the nums array, nums binary array. So you will be going element by element. Okay, let's try to go element by element. When we are flipping, like what do we want at the end? Our array has to contain all ones here. So I will look at this thing and I will say that, is it 1? No, it is 0. So when it is 0, what I will do is, I will take the 3 consecutive elements and I will flip it. I will take 3 consecutive elements and I will flip it. So here when I flip it, 1 0 0 1 double 0 here. Now we were at this one. Now I will be here. Now when I am here, is it 1 or is it 0? It is 0. That means again I have to take the next 3 consecutive elements and I have to flip it. 1 1, like 3 consecutive elements would be this one. So 1 1 1 0 0 0. Next I would pick the next element here. Now when I pick the next element, is it 1 or 0? It's already 1. So I do not have to do anything. See, this was my first, this is second operation. See, if you look at in the third one, I'm not flipping anything because it's already 1. So I won't be considering the, I won't be increasing my number of operations. Now, what is the next element here? 1 1 1 0 0 0. That means the next element would be 0 again here. Now, do I have to flip it? Yes or no? When it is 0, I need to flip it to 1. So, what is my strategy for flipping, or what is given in the problem? I need to take 3 consecutive elements for sure, and I have to flip all of them. So, I will be taking the 3 consecutive elements here as well. As I am converting 0 to 1, I will be incrementing my number of operations here. Total number of operations still now will become 3. Again, I will flip everything to 1 here and I will check. Are all the elements of the, like, I will not check, not that. I will move to the array elements again. What is the next element that I have to flip here? This one. But is it 0? No, it is already 1. And you need to look one more thing. If let's suppose this was 0, here for now it is 1, that is fine. But somehow if it was 0, can I choose the 3 consecutive elements from here? I can choose only 2 here, yes or no? I can choose only 2 elements. I cannot take 3 elements from here. So can I say that, see, consecutive elements means I plus 1, I plus 2 here. Now I cannot choose, like I is there, I plus 1 is there, but I plus 2 will be index out of range here, yes or no? So in that case, I won't be checking these indexes. I will be doing whatever the operations are there till n minus 3 only, okay? Because if I do for the remaining thing, it will be index out of bound. And after entire thing is done, I will be checking in my array if it is contains 0. If it is contains, still it contains 0, that means it's impossible to make all the elements of the nums array equals to 0. This was our logic. And if I have to write the code here, code would be pretty simple. First, I will be having my number of operations equal to 0. I will starting from my int I equal to 0. I will be going till, as I said, I will be going till n minus 3 I plus plus. If nums of I equal to 0, I will be incrementing my operation here. After incrementing the operations, I need to make the consecutive 3 elements to 1. Like I have to flip it. So how do I flip? What are all indexes? First would be nums of I, second would be nums of I plus 1, and the one more element would be I plus 2. How do I flip? What is mean by flip? As I already mentioned, I have to, if it is 0, I have to convert it to 1. If it is 1, I have to make it to 0. There are many ways of flipping. One is 1 minus nums of I also we can do. 1 minus nums of I. My bad. Uh, Here it has to be nums of I. Nums of I. Here as well. Nums of I. This is the one way. Or you can do other way as well. Like 1 XOR nums of I here as well as 1 XOR nums of I. It is still the same thing, like 1 XOR nums of 1, like I plus 1, 1 XOR nums of I plus 2. Now once we are done with all the operations, we need to check if it still contains 0 or not. So I starting from 0, I less than n, I plus plus. If nums of I equal to 0, I will be returning -1, or else I will be returning whatever the number of operations are. This is the straightforward code. Okay, so whatever we have discussed in the problem, we are going to do the same thing in the number of operations. Let's say equal to 0. Actually, this is a standard Leetcode problem. Int I equal to 0. As I said, we will be going till n minus 3 only. Nums dot size -3 I plus plus. You don't have to worry about like do we have 3 elements. If you look at in the constants, for sure we are going to have the 3 elements here. Now if nums of I equal to 0, I need to like flip here. For flipping, as I said, nums of I can say here nums of I. Same thing I can do for the whatever we are having, like 3 consecutive elements. As I said, 3 consecutive elements will be I plus 1 and I plus 2 here. Now once this is done, again I need to check, do I still have if still I have 0 after doing all the operations, I will be returning 0 from there. Or not 0, I need to return -1 because it's impossible to make. If that is not the case, I will be returning the number of operations. Okay, here we are not increasing the operations, so I need to increase the operations as well. Let's try to run the code. Wrong answer. Okay, it's giving a wrong answer. Here instead of taking the -3, we need to take -2 because we need to go till like from the last third element, and I think now it is passing both the cases. Now I can submit it here. It is accepted. So that's it for the second solution. Okay, let's try to see the third problem, that is minimum operations to make binary array elements equal to 1. This is the second variation of the second problem. So here as well you will be given a binary array nums. Already we have discussed what is a binary array. Now here we can do the following operations on the array any number of times, possibly 0. Same thing was given in the previous problem as well. So in the previous problem it was given that we can choose any 3 consecutive elements and we can flip it, but here it is given that choose any index I from the array and flip all the elements from I to the end of the array. So here it is not given the 3 consecutive elements, but here it is given that if I choose any I, okay, let's say this is our array, and if I choose any ith index, I need to flip all the elements from index I to the end of the array. Flipping an element means changing its value from 0 to 1 and from 1 to 0. We need to return the minimum number of operations required to make all the elements in nums array equal to 0. Same thing as previous, but only thing that is changing here is previously 3, what we were flipping, if I am selecting some index I, we were flipping the 3 consecutive elements. Yes or no? 3 consecutive elements. But here what is given? We need to flip all the elements from index I to end of the array. Let's try to see the first example here. Nums array given something like this, 0 1 1 0 1. That means if I am selecting this index 0, if this is index 0 1 2 3 and 4, if I am selecting the index 0, I need to flip all the elements from index 0 to index 4 here. That means my in first operation my element will be something like 1 0 0 1 0 here. Now again when I go to the second one, again it's 0. So what will happen? 1 comma 1 0. That means all this will be flipped 1 1 0 and 1. One operation, second operation, in third operation, like do we need to perform operation here? It's already 1. No need to perform any operation. No. 1 1 1. Now when I am at the here, do I have to perform the operation? Yes, it is 0. I need to perform the operation. So when I perform the operation, what will happen? From index here, that is index 0 1 2 3 to at the end of the array I need to flip. That means these two will be get to flipped here. So how it will look? 1 1 1 1 comma 0. Now again we will be at this, again we need to flip. That means one more flip will be required. Now what will happen? 1 1 1 1 and 1, and all the elements of the nums array will be 1 here. Okay, that is the thing. But if you try to solve this problem brute force, like whatever is the problem, if you try to solve like that brute force, you will be getting a TLE. Why so? Because here if you look at what is the size of the array, 10 power 5. Constants is given is 10 power 5. And what is the time complexity or solution? What we are thinking? So if you look at the time complexity or solution, let's try to write the pseudocode first of our brute force solution here. We thought like we will be going from 0, we'll be like starting from 0, we'll be going till n. Whenever I am finding a 0, like nums of I, force code, whenever I am finding a 0, what I need to do? I need to write one more loop into j equal to I, j less than n, j plus plus. Now I need to flip each and everything, that is nums of j equals to, already we know how to flip it, 1 XOR nums of j. One more thing, we need to increase the number of operations as well. Operations we will be incrementing. At the end we will be returning the number of operations. What is the time complexity here? This is taking n time, and this will also take n time. So can I say that this will be like n square time complexity? Yes or no? N square time complexity. Now as we saw in the constraints, n was given as something like 10 power 5. So this will be around 10 power 10. And if we write a code that is taking 10 power 10 iterations, you will be getting a TL. You can try submitting as well. You will see that you will get a TL. Now, what is taking time here? Flipping. Yes or no? See, once I find something is 0, like one of the element is 0, nums of I equal to 0, this flipping is taking extra n time. Somehow I need to eliminate this. Yes or no? Somehow I need to eliminate this thing. How can I do so? Okay. somehow if I know when I am here, okay, let's try to look at this example one more time. Let's say, for example, if I am here, let's say suppose when I am here, okay, started from here, I went here, and now I am at the index 2. Somehow if I know the value of 1 here, when I'm at this index, if I somehow know the value of this whether it is 0 or whether it is 1, because of the previous elements, what can happen, this element can be 1 or this element can be 0, yes or no. We are not talking about the all the elements here. I'm only talking about the current element. It can be 1 or it can be 0 as well. Now can you guys tell me when this will be flipped to 0, when this will be flipped to 1? Can I say that when I am coming from here to here, if I am having odd number of zeros, like odd times zeros, we will be flipping this element, we will be flipping, yes or no, we will flip the current element. If it is even times, do I have to flip? No need to flip, because what is happening, flip again, one more time flip, it will be back to original state. Like when we flip even times, what will happen, it will be coming back to original state, and I do not have to flip it. I do not have to flip it means value would be 1. When I'm having previously odd number of zeros, like odd occurrences of 0, that means I need to flip it. When I flip 1, it will become 0. So I hope it is clear that based on the previous occurrences of 0, we can predict the current value as well, current index value as well, whether it is 0 or whether it is 1. Like, do I have to flip it or do I do not have to flip it? I told you the conditions as well, when I need to flip, when I don't have to flip. Okay, we'll be taking this example only and we will be moving further. Let me remove all these things. Okay, I am here. Occurrences of, let's say, 0, count of 0 till now is 0. Count of 0 till now is 0. Now when I am here, what is the count of 0? 0, which is nothing but even. So it has to be in original state. When it is in the original state and it is 0, I need to make it 1. Yes or no? I need to make it 1. I have to make it as 1. So what will happen? I will also make something as number of operations as well. Initially number of operations is also 0. Now when I flip this 0 to 1, that means my number of operations will increase. Now before I move further to the next index, I need to increment my count of 0 to 1, because here the count of 0 was 0. Now this was 0, so my count of 0 will increase. Now I will move to the next element here. Now how many occurrences of 0 I had previously? 1. That means I need to flip this element. Yes or no? I need to flip this element. Now I will flip this element and this will become 0. This becomes 0. Again I have to make it 1. Now to make it 1, what will happen? My number of occurrences will increase. My count of 0 will also increase to 2 here again. Now when I am at the second index, should I flip it or should it be 1 only? Count of 0 is 2, that means previous count of zeros were 2. Yes or no? I do not have to flip it. Is it 0? Is the original element 0? No, it is not 0, it is 1. So I do not have to do anything. I can move to the next element. What is the next element? 0. When it is 0, I don't have to flip, because count of previous zeros were 2 only. That means originally it was 0. Like here now it is 0 only. So I have to flip this 0 to 1. When I flip this 0 to 1, my number of operations will increase. Count of zeros will also increase to 3 here. Now I can move to the next element. Now again count of zeros. Previously how many times zeros were occurred? 3 times. One time here, one time here, and one time here. 3. That means this state needs to be changed. Whether it is 0, it will become 1. When it is 1, it will become 0. So now when it is 1, it will become 0. Now when it is 0, that means I need to update my number of operations as well to convert it to 1, and count of zeros will become 4. And if you look at all the elements of the array is equal to 1 here. Minimum number of operations that we take is 4 here. Same thing. I hope the logic is clear for this part. If this is clear, we can move to the code part. Okay, what we need to do in the code part, same thing as we have discussed. Like we need a number of operations. Initially this will be 0. Initially count of 0 as well will be 0. Now I will be going into I equal to 0, I less than nums dot size. If what I need to check, count of 0 first. Is it odd or even? When it is 1, that means I need to flip it for sure. I need to flip it. So I will be saying nums of I as 1 XOR nums of I. And if nums of I equal to 0, that means if it is 0, what will happen? I need to increase my number of operations. I need to increase the count of 0 as well. And I need to flip it to 1. That would be nums of I equals to 1 XOR nums of I. At the end I can return the return operations. Let's try to run the code. Let's try to submit it as well. That's it for the third solution. If you find this video is informative, do share with your friends. For more such content, do like, subscribe and share Smart Intuitive channel. Until next video, this is Ankit Patel signing off.